Okay, we're back. This is AP Physics 1 check-in number 4. This one has to do with circular motion. So we're going to ask a couple questions here. If you haven't seen the questions, go ahead and take a look at them, pause, see if you can answer them, and then we'll come back. This one's about uniform circular motion, sometimes abbreviated UCM. First question, what is the name of the force that acts toward the center of the circle? You should be aware and be able to state pretty quickly that we are going to call that the centripetal force. What is the reaction force to the centripetal force? Not sure if you're familiar with that, but because we try not to use that as the reason for why an object goes in circular motion, but we call it a centrifugal force. Centrifugal force. What is the direction of the velocity of an object in uniform circular motion? The velocity is always tangent to the path. The word we're looking for is tangent. And what supplies the centripetal force for a satellite orbiting the Earth? What might do that? Because we said there was always a force that did it. In this case, you would be correct to say that the gravitational force between the Earth and the satellite is what puts it in that orbit. Hopefully those are the answers you had for that. Let's go ahead quickly to the next question. This one has to do with a roller coaster. You're simulating the top of the circle. The circle is this one right here. Radius would be from the top all the way to the halfway point. So we're simulating that as we go into the top of the circle. The radius of the path for this would be 12.5 meters. And the force due to gravity, the weight of the object, is known to be 525 newtons. It asks you to draw a free body diagram for this situation. Well, I would expect the force due to gravity to act downward. Since the object is right side up, the normal force comes from underneath, and that would be upwards. I think that's your free body diagram, is downward force due to gravity and an upward normal force. The next question says, which force of the two would be the largest in your free body diagram? FBD standing for free body diagram. And the answer to that is the force due to gravity has to be greater than the normal force in this case. Do you know why? I think the answer is the fact that you know that this object has to be accelerating downward toward the center of the circle, because that's what a centripetal force is. And if that's the case, then if you think of a tug of war, then the team that has to win is in the direction of the acceleration. Therefore, the gravitational force has to be greater than the normal force. Hopefully that makes sense. If you know, if we're using that same situation, at the top of the path, the velocity is 7.45 meters per second, what is the force the seat exerts on the student? That's also asking, then what is the normal force? So the way in which you'd calculate that is to say, well, A is F net over M. The net force in that case would be the force due to gravity minus the normal force, because it's a tug of war and we said that the force due to gravity wins over the mass. The only other thing we have to add in is for circular motion, that acceleration is equal to v squared over r. So A is v squared over r. In this case, then, if we put the thing together and want to solve algebraically for Fn, it's going to be equal to, move the m to the other side, it's going to be Fg plus, minus mv squared over r. Minus mv squared over r. Again, it's got to be less than the force due to gravity. So you could just plug in your numbers. Fg was 525 newtons. In this case, if you go back to that, you would probably have to calculate what the mass is by taking 525 and dividing by 9.8. If you do that, I get like 53.6 kilograms. So that would be 53.6 kilograms times v squared, 7.45 meters per second. We're going to square that and then divide by 12.5 meters. and that's going to go ahead and give you what the normal force is. And if you do that, you get 287 newtons. I would ask you to go back through and make sure that that makes sense, but it is a number less than 525 as we would have suggested. The next part of the problem says, what is the maximum speed the roller coaster can travel and still keep the student in the seat? At first, when students read those maximum speed type questions, it throws them a little bit. But the idea is, if you look at this equation, if you're going to get the maximum value for v, that's going to be when you rewrite that v squared over r, that's going to be when this is, you're going to subtract off the least amount you can. Wouldn't that be true when that's 0? So if that's the case, and you put in 0 for Fn, you get Fg, which is just m times 9.8 over m, is equal to the V max squared over the radius. The masses cancel, and so we can calculate pretty quickly. V max is going to be g times r, and then we're going to take the square root. Pretty straightforward calculation. You could take 9.8, multiply by 12.5, and then take the square root. And if you do that, I have here that the answer for that is 11.1 meters per second. Does that make sense? Okay. We're going to go on to the last problem then. And that is a satellite in motion around the Earth. So you have this object, satellite is orbiting the Earth, and you see that in the picture. For part A of this, note that the radius of the whole path is the radius of the Earth plus the height. And the height in this problem is given as 1.25 million meters times 10 to the 6th. And they want to know what is the speed of the satellite that keeps it in a circular motion. So if you shoot it with that tangential velocity that it has to have at any point, it's always tangent to the path, that will keep it in that horizontal circular path. Well, how do you go about doing that kind of problem? Well, you remember in class we probably derived several equations, and the idea is if you want to show how to get the velocity, you're going to say, well, the centripetal force has to be supplied by gravity. And you should be able to show this on an AP test, is that this would be the mass of the satellite times v squared over r. That's what centripetal force is equal to. On the other side, that's equal to g from Newton's law of universal gravitation, gmm, that's the mass of the Earth, over r squared. Again, r is that total distance of the radius plus the height. We have some cancellation. The mass of this satellite cancels, so it doesn't matter what the satellite has in terms of a mass. What this ends up being is g mass of the Earth over r, and take the square root. And so you'd have to look up some data for that. Maybe I'll just remind you of some of these numbers. 6.67 times 10 to the negative 11th. I don't have a lot of space, so maybe I'm going to cancel out the units for right now. The mass of the Earth is 5.98, and that's e to the 24 times 10 to the 24th kilograms. And in this case, the radius of the Earth is 6.38 times 10 to the 6th. And then we're going to add to that, what was that number up here, 1.25 times 10 to the 6th. And if you do that, see if you get the number that I got. I got 7,230 meters per second as the velocity of the satellite in that orbit at that distance. Something that I know showed up on one of the AP tests in the last couple of years in AP Physics 1, where you actually had to show that derivation to get it right. So that's the first step of this problem. They then ask, what is the acceleration of the satellite in that orbit? Well, you could do a derivation to find acceleration, or you can just go from the straight definition. A is v squared over r. Then if that's the case, then you could just put in the number 7,230 meters per second, which was what you got in the last problem, and then divide by that number when you add the radius of the Earth plus the height. So I'll just write that in as a variable, and then you go ahead and put in the numbers. But if you do that, you should be able to get what the acceleration, and basically that's the acceleration due to gravity, would be. And it turns out that it's 6.85. It's no longer 9.8 because you're not on the surface of the Earth. The acceleration is reduced to 6.85 meters per second squared. Okay, the last step on this one would be to say, what is the period of revolution? So how long does it take for it to go all the way around one time? Well, we know that velocity is just distance over time, but that's a specific distance, the circumference, 2 pi r, over the period, and that's what you're now looking for. You're looking to find the period, so wouldn't that be the circumference 2 pi r over the velocity? And so it's a pretty straightforward calculation. 2 pi times, put in the radius of the Earth plus the height, and then divide by the 7,230 meters per second. And if you do that, you end up getting 6,631 seconds. Okay? I hope that tells you enough for this one. Thanks a lot. We'll talk to you next time. Stay safe.